In this module, I'm going to show you how to certify an M12 patch cable. Before we do that, we need to reference our two units here on the DTX cable analyzer. So a permanent link adapter is connected to the main unit and a channel adapter connected to the remote unit. Then my permanent link adapter into the channel adapter. You hear the chirp to tell me they're connected. I rotate the dial to special functions, and with set reference highlighted, I hit the enter key. It shows a little picture of my setup to help me. Hit the test key and off it goes. This is something that I'm going to want to do each day. OK, and it's done. So we press F2, OK. I can now remove these adapters and we are done with those for today. Fluke and Fluke Networks offers these DTX-CU-104 adapters which have the M12 connector in the top, which is going to allow us to do the patch cord certification. The M12 is keyed, so we need to very carefully find the key and place it on there. Same on the main unit as well. I don't need to screw these in, not for the purpose of certification. Rotate the dial to auto test, and my test limit is currently selected for Cat6 permanent link. I need to change that. So I rotate the dial to setup, and with twisted pair highlighted, I hit the enter key. And with test limit highlighted, I hit the enter key again. On this screen here, it will show the last 9 test limits that you selected, and we don't have the one here that we want, so we need to press F1 more. Then we go to TIA and hit enter, and if we scroll down, we'll see the Industrial Ethernet Standard TIA 1005. This is actually the wrong test limit to select. Why? Because it has the word channel in the test limit. Whenever you see the word channel in the test limit, it means that we're not measuring the first connection and we're not measuring the last connection. The TIA and international standards are very specific in that you exclude the first and the last connections to the test equipment. So we'll hit F1 more and we'll go down until we find M12 patch cords and hit the enter key. You'll notice that the length changes as you go down the screen here, because the shorter the patch cord, the tighter the near end crosstalk requirement. I have a 2 meter patch cord here, actually it's 2.1 meters, so I'm going to go and select 2 meters and hit the enter key. Then I need to change my cable type. It's currently set to Cat6 unshielded twisted pair, UTP. So I'm going to hit enter, enter again, and select Cat5e, because this is a Cat5e unshielded twisted pair patch cord. Then my MVP, the nominal velocity of propagation. Don't be intimidated by this. This value here will only affect the length reported by the tester, and given we're only measuring 2.1 meters, it's not that critical. However, contact the cable vendor and find out what the MVP of their cable is. Simply put the figure in here, and then your length reading is going to be spot on. The final setting we need to be concerned about is outlet configuration. It's currently set to T568B. That's a 4-pair standard, and we've only got 2 pairs in the cable here. So we need to change that. I could select Ethernet 2-pair because it's industrial Ethernet and it's 2 pairs. But I'm going to go down until I find M12 2-pair. We put that in there as an additional aid to help people find the right outlet configuration. You'll also notice that we have M-pair, M12 2-pair crossed. So if you're connecting 2 switches or 2 hubs together, you require a patch cord where the pairs are crossed, so that transmit goes to receive and receive to transmit. This is a straight through patch cord, so I'm going to go and select M12 2 pair. Then rotate my dial to auto test and hit the test key. You're about to see that this is a really quick test. There's my result. And what we see here is our wire map, our resistance, our length, propagation delay, and delay skew. Now you'll notice that with resistance, length, propagation delay, and delay skew, they have the letter I next to them. That means information only. That's because when you're doing patch cord certification, there is no limit for resistance, length, propagation, delay, skew. But customers want to know those values, so we actually make the measurement and record them. When you're doing patch cord certification, you're primarily interested in two parameters: return loss and near-end crosstalk, or next. Return loss is the amount of signal reflected back. The tester has all the limits in there, so it does this calculation for you against the standards. You don't have to get a calculator out and do all the logs and all that stuff. What it will provide you with is a value here on the right, in this case 4 dB. That's how much above the standard you are worst case. Now, what is a good value here? Anything above 0. If it's below 0, you would have seen a fail appear in the top right hand corner here. Do you want to be 0.1 dB? Not really. You really want to be a little bit more above than the standard. The standard is the bare minimum after all. And then we see near-end crosstalk showing 16.2 dB decibels. Is that a good figure or a bad figure? Well, 6 dB is a factor of 2. So this is a really nice patch cord. Whoever did the termination of this M12 here and here clearly maintained the twists going into the back extremely well, coupled with a very nice performing cable, gives us excellent margin. I could hit the save key, save this result, and print it out with this patch cord to prove that I certified this patch cord. And that is how you certify an M12 D-type coded industrial Ethernet patch cord.